So in this video, we are going to be looking at the rest of the periodic trends. So remember in the first video, we talked about electron shielding, we talked about the trend we see with atomic radius, and we talked about how the radius of an atom changes when we look at ions. In today's video, we're going to be looking at a concept called first ionization energy, electronegativity, and then trends we see with melting and boiling points, density, and atomic mass in the periodic table. So the first trend that we're going to be looking at when we are talking about periodic trends in today's video is that of first ionization energy. And first ionization energy means the energy required to remove the most loosely held electron from an atom. And so generally that electron is going to be a valence electron. So it's the amount of energy required to remove a valence electron. And for this trend, we see that it is going to increase up a group and increase as we move to the right across a period. So the overall trend can be drawn like this. And why do we think this trend is opposite of the trend seen for atomic radius? Well, the reason is that the closer the valence electrons are to the nucleus, the harder it is to remove them. And remember, those electrons in the valence shell are going to be drawn to the nucleus as we increase the number of valence electrons. So as we move across the period, remember we're increasing the number of valence electrons in that outermost shell. So that is why we see ionization energy increasing as we go to the right across the period, because as we increase the valence electrons, we're increasing that outermost shell's attraction to the nucleus. So if we're increasing that attraction, it's going to be really hard to pull a valence electron away, which is why it's going to require a lot of energy. So the next trend we're going to be looking at is called electronegativity. And electronegativity can be defined as the tendency of an atom to attract a bonding pair of electrons. Or even more simply put, the tendency of an atom to gain extra electrons. And so when we're looking at this trend, we are going to see that it is actually the same as the trend for ionization energy. And what we want to be thinking about is, why do we think that trend is going to be the same as the one for ionization energy? And the reason is the atoms that have a higher ionization energy have more electrons in their valence shell, which means that they're closer to a full valence shell and therefore more likely to gain extra electrons. This also explains why we see anions on the right-hand side of the periodic table. Remember, anions are those negatively charged ions. So those nonmetals, because they have more electrons in their valence shell, are more likely to gain those extra electrons. So one way to think about it is to think about a specific element. So think about fluorine, for example. So fluorine is in group 17, and that means that fluorine has 7 valence electrons. Is it going to be easier for fluorine? So remember, all atoms want to have a perfect valence shell, which is 8 valence electrons. So we have to think to ourselves, is it going to be easier for fluorine to gain an extra electron or to lose the 7 electrons it has? And it's going to be easier for it to gain that 1 electron. And because it's easier for it to gain that 1 electron, it's going to have a higher tendency of gaining that electron because it just wants that one more electron in order to be completely stable. So it's going to have a higher electronegativity. So the next trend we're going to be looking at is that of melting and boiling points. And here we just need to recap a little bit about what a periodic trend is. So remember, periodic trends have to happen, have to be changes consistently happening in both the period and the group. So when we look at this image here of melting points on the periodic table, do we see a trend there? And the answer should be yes, we see a trend. If I were to draw a box to represent my periodic table, I can see that the melting and boiling points are going to increase as I move closer to the center of the periodic table. But what I don't see is consistent changes happening across the period or down the group. So we would not say that melting and boiling point is a periodic trend, even though we do see a trend happening on the periodic table. So let's look at another one. Here we're looking at density. Do we see a trend happening with density? And the answer would be yes. We see that as we move down a group, the higher the density. And it also looks like, at least in that 7th period, as you move towards the center of the periodic table, the density increases. But because we're not seeing consistent changes in both the period and the group, it would not be considered periodic. So the last trend that we're going to be looking at is that of atomic mass. And so the image in the bottom right-hand corner is showing us different bubbles to represent increasing atomic masses. So if we look going down a group, we can see that as we go down a group, pretty clearly we see that that overall atomic mass is going to increase. Looking across the period, it is a little bit harder, but if you look really carefully, you'll see that as you move across the period, the circles are getting just a little bit larger. So if we were to draw the overall trend, we see that we're increasing as we're going down a group and increasing as we move across a period. So the overall trend of atomic mass would be this. So we know that there is a trend, and because we see it happening in both the group and the period, we would say that that trend is periodic. So the last thing we're going to do in this video is kind of go through a helpful hint to try and memorize some of the trends on the periodic table. So the first thing would be to draw a snowman. And I know this sounds silly, but just bear with me. So we're going to draw a snowman, and the base of our snowman is going to end in the bottom left-hand corner of the periodic table. And so what this is showing us is that as you move down the group, atomic radius is increasing. Well, if I were to happen to knock my snowman over, now the head is going to be pointing towards the right-hand side of the periodic table, which helps remind us that as we move across the period, our atomic radius is going to get smaller. And if we can remember that this is the trend we see for atomic radius, and we remember that ionization energy and electronegativity are opposite of atomic radius, then perhaps we'll be able to remember at least those 3 periodic trends using this way. And if this doesn't work for you, that's totally fine. But just in case you want some way to kind of kickstart your memorization of those trends, I'm going to leave this here for you.